This is a conversation between the first physicist who made the explicit link between quantum mechanics and consciousness, Sir Roger Penrose, and the inventor of the microprocessor, Federico Faggin, who is also a physicist and has just written a book about his own quantum theory of consciousness.
Why should consciousness even exist if it has no causal power? That's my question.
I would agree that clearly it does exist, and I think I agree with you there. The fact that it can have a causal effect is the only reason why beings have evolved with it.
Roger Penrose and Federico Faggin agree on one important point when it comes to consciousness. It cannot be computed.
A computer, in the sense that we mean it, which is a computational system, will not ever be intelligent.
Understanding, intelligence, consciousness are words that are often used interchangeably by Roger Penrose, and according to him they involve quantum mechanics. For more than 2 decades he's been working on a theory about quantum effects in microtubuli in the human brain that recently seemed to be substantiated by empirical findings. Now Federico Faggin in a sense builds on Penrose's ideas, but not in the way you would think. According to Faggin, consciousness is not caused by wave function collapse, it's more fundamental. Quantum fields themselves are consciousness. Collapse then is just consciousness expressing itself.
Consciousness and free will must be postulates. It must be a postulate in the sense that consciousness and free will cannot be explained in any simpler ways than the fact that they exist. If you start with consciousness and free will existing, we can then explain why quantum physics has to have the crazy properties that it has.
Here Penrose disagrees, mainly because he is dissatisfied with quantum theory altogether. According to him, it's not a complete theory because it leaves out an understanding of what wave function collapse actually is.
Well, as Einstein and Schrödinger said about it, it's an incomplete theory. I'm not as polite as they are. They were saying it's incomplete. I would say it's actually not even quite correct. And what has to go on in the brain, in the conscious being, what has to be something which is not just evolving according to current quantum mechanics, it's evolving according to that theory we don't yet have, which is the more complete theory in which the collapse of the wave function is part of that theory.
As a philosopher moderator who understands quantum theory, we had Bernardo Kastrup join in, who stirred things up a bit.
Federico and I dare be with Federico on this one and not with Sir Roger. I don't think collapse really happens. I think if we eventually get to a deeper understanding of what's going on, I think we'll realize that there is no collapse. It's an epistemic. It's a transition from an epistemic idea to an ontological one.
Sir Roger is raising his hand to his forehead.
But I don't see how you can say it doesn't happen. I mean, you have to have something which looks more or less like the classical world. And if you don't have the collapse of the wave function, the quantum evolution of a state does not look like the classical world.
In this conversation between Penrose, Faggin and Kastrup, we hit on the mysterious divide between the quantum and the classical world and how it relates to consciousness. Penrose, perhaps the oldest and wisest, made a confession, namely that he once tried to close the quantum classical gap by believing in the many worlds interpretation of quantum mechanics.
Is that it's a good thing to have had in certain stage of your life to have believed in the many worlds interpretation of quantum mechanics. The shorter period, the better. I did go through such a stage myself, of believing in the many worlds interpretation.
Welcome to the Essentia Foundation's YouTube channel, and before you watch further, may I ask you to like and subscribe, because it really helps us to produce content like this. And I advise you to turn on subtitles below for a better viewing experience. Enjoy the conversation. First of all, a very warm welcome for Sir Roger Penrose, who's joining us from Oxford, and known to be one of the greatest physicists of our time, Nobel laureate, and someone who has made huge contributions outside of physics as well, studying consciousness and coming up with a testable theory about the relationship between quantum mechanics and consciousness. Then we have Federico Faggin, inventor of the first microprocessor, the touchpad technology and the touchscreen technology, and one of the founding fathers of neural networks, who now also has a theory about the relationship between quantum mechanics and consciousness. And to me, sort of the catalyst in meeting both of you gentlemen has been this gentleman here sitting next across the table, Bernardo Kastrup. And Bernardo, it was through an episode I did on conscious AI that had you in it, Sir Roger, with your chessboard position. And Bernardo, you knew Federico, and now we're sitting here, and I just find that beautiful. And I want to really give the three of you time to get to know each other. And I think it's good to first start with your theory, Sir Roger. And I previously interviewed you in 2021, and then in 2022, I followed this news website that said that your colleague Larios Giosi had come up with experiments that made it very difficult to have your theory still be credible, because you would say that quantum effects cannot be possible in microtubules. But then 2 months ago, I read in a journal a paper coming out saying that these effects are now experimentally established. So I thought Sir Roger must now be triumphant that the experiments are now in favor. So I'm very curious where you now are with your theory.
Well, as far as experiments are concerned, I think one has to be a bit cautious about it all. So I'm not an expert on experiments, but I certainly have a colleague who, although the recent experiments you refer to seem to be supportive of the point of view I'm putting forward, he was a bit skeptical, thinking it might be a bit wishful thinking, experiments. So I just have a neutral position on this. I can't really judge the experiments. And exactly how one might make observations, experimental observations, to see whether the argument would have to be that one has quantum effects in microtubules, these little tiny parts of cells. And this has been the argument for quite a long time, ever since I had a communication from Stuart Hameroff. I'd written my book, The Emperor's New Mind, which was trying to put forward my viewpoint with regard to consciousness. And at that time, I had no idea how you could find anything in the brain which seemed to support what I was doing. And it was interesting to hear from Stuart Hameroff, who read my book, and his job was to do with consciousness, namely to turn it off in a reversible way, because he's an anesthesiologist. He was at the time, he's now retired, at the University of Arizona. And he introduced me to the notion of microtubules, of which I was completely ignorant previously. I'm not a biologist, I'm not a physiologist. I don't know the details of what's going on, so I have to trust other people when it comes to that. But the arguments that I had originally came from mathematical logic. I had attended, as a graduate student, 3 courses that were nothing whatsoever to do with what I should have been doing, which had to do with pure mathematics, algebraic geometry at the time. And one of the lectures I went to was a lecture given by a man called Steen on mathematical logic. And he explained how the Gödel theorem worked, and what the notion of computability I learned from him too, as a definite thing in mathematics, and that there are certain mathematical problems which don't have a computable solution. I mean, they have a solution of some sort, but they're not solutions that you can put on a computer. So I was aware that there were such things. And that what I found most striking about Steen's lectures was when he came to the Gödel theorems, and I was a little bit disturbed by the idea of Gödel's theorems, because I'd heard about them before going to graduate work, and I wasn't very happy with the idea that it seemed to show there were things in mathematics you couldn't prove. What I found reassuring was that the actual argument, the Gödel argument, is to show if you have any system of proofs which you accept as acceptable as proofs, and you could in principle put them on a computer, then what Gödel shows, how you construct a sentence, very clever way, which you could see is not provable by those rules. But what struck me as most remarkable and most reassuring in a way was that your understanding of why the rules work enable you to transcend the use of the rules. So it's understanding why the rules work, which enables you to see why the Gödel theorem is true. You see that it's true, but not derivable by those rules. But it is derivable by your understanding why those rules are actually correct for the mathematical results. Yeah.
This also leads, of course, to that chess position that you showed me then, which had to do, right, with AIs. A halting problem is triggered, so to speak. And the human mind somehow, because it understands chess, can solve the puzzle, whereas AIs will just start computing forever.
Well, yes, but I guess that particular example, probably the computers have grown in power since then, and it may well be that they could solve that particular problem. But any specific problem in chess is a computable issue. So
I think nice because we have a founding father of the microprocessor sitting on the other side of the table. Federico, to share with Sir Roger your view about why consciousness cannot be computable.
Yeah. Well, my ideas start by saying that consciousness and free will must be postulates. It must be a postulate in the sense that consciousness and free will cannot be explained in any simpler ways than the fact that they exist. And we have the proof within ourselves. It can be a subjective proof, but it is a proof within ourselves. So if for a second then we start there, and by the way, that postulate is self-evident because we all know that we are conscious and we all know that we have a certain modicum of free will. So starting there, then together with the Professor Giacomo Mauro D'Ariano, which you may know is a expert in information, quantum information, and he is the one that actually showed that if you start with 6 postulates that are quantum informational based, you can derive quantum physics out of them. So with D'Ariano, we came up with a way of thinking about consciousness that makes a lot of sense to me, and that is that if you start with consciousness and free will existing, we can then explain why quantum physics has to have the crazy properties that it has. Specifically, we can explain why quantum information has to have the no-cloning theorem and Olivos theorem, which we can discuss a little later, and then why the collapse of the wave functions cannot really exist as such, but it is a expression of a free will decision of a field that has consciousness and free will. So consciousness and free will are then causing, in a sense, the physics, which is the informational aspect, not the meaning aspect, not the semantic aspect, but the informational, the semantic aspect of reality to manifest the way it does. So, with this theory then, not only does it make sense to start with a consciousness and free will existing and being true by definition and being fundamental properties of all the fields, of quantum fields. The quantum field of electrons is conscious, is self-knowing, is within the consciousness itself. And the symbols used to communicate, which must be shareable, existing in space-time, are the excited states of the fields, which are what we call electrons. But the electrons then in this idea, in this way of understanding reality, are just the symbolic aspects of reality, where the semantic aspects of reality are within the field itself. So this theory seems to then explain, to really show that our conscious experience is, in particular, qualia, that is the perceptual way in which we understand reality, we begin to understand reality, we have these sensations and feelings that allow us to understand reality, that perceptual qualia are represented by quantum information, because quantum information is private, it cannot be reproduced, no cloning theorem, and also what we can say about, or we can measure about that state is only 1 bit per quantum bit. So, which is exactly what we do, because what I feel, when I transform what I feel in symbols, in outer symbols, shareable symbol, classical information, those symbols are in fact only a small portion of what I feel. The love that I feel within myself for a son, for example, it's not a number, and it has dimensions that go way beyond any possible measurement. It's a dynamic form. It has depth of perception that I need to understand within myself. So qualia can be represented by a quantum state, a pure quantum state. So anyway, this is the essence of this theory.
Sir Roger, before I give you an opportunity to reflect on this, because this is, of course, a whole theory, and there's, I think, 100 things to say about this proposal Federico is making. May I ask you, Bernardo, you have an understanding of Sir Roger's work and theory and an understanding of Federico's. Where do you see the main differences, and what do you think is the good question now for Sir Roger to reflect on hearing this new theory of consciousness?
Yeah, I can't compare to these two giants, but I'm looking in from the outside and I try to make sense of what they've been saying. Sir Roger, in The Emperor's New Mind, which I think is from 1988 or 89, 88, right? I think.
Yes, I don't think that is around about then, yeah, 89.
The key point I think he makes is that consciousness can jump out of the system. Consciousness is not a formal system. In other words, a system of axioms and rules of derivation that you can produce theorems out of it. Consciousness can step out of that formal system and acquire a form of insight that cannot be formalized that way. And that may have something to do with quantum mechanics, because quantum mechanics doesn't seem to match with Aristotelian logic. So it gives us an opportunity or a way of thinking about how physical systems or how natural systems could not be just a formal system. So that's the link there. It's the jump outside of formal systems that is linked with quantum mechanics in some way. Federico comes at it perhaps from the other side and meets Sir Roger's ideas. Federico says, things as they are in themselves are conscious states. And our best model of these conscious states, of things as they are in themselves, is a quantum mechanical description of a quantum state in Hilbert space. So what his interpretation is that quantum mechanical descriptions of systems in a superposition are our models of things as they are in themselves. And things as they are in themselves are experiential states. And what we call physical states or classical states after decoherence or after collapse, whatever happens actually there, they are symbols, syntactical representations of internal quantum states, which contain much less information than the internal quantum state, because a quantum state is you could say it's an infinite superposition of possible states, while when you make a measurement of that, you only get 1 bit per quantum bit, which is much less information in a certain way of interpreting information. So Federico makes the same link that it is the non-classicality, it is the aspect of a system that isn't just captured in a formal set of rules of derivation and axioms that is linked with quantum mechanics, and that touches on Sir Roger's idea as well. Sir Roger's comes from the opposite side, and I think they may meet in the middle. Maybe it's a naive perspective, but that's how I interpret them.
I think that there is a lot in common.
Sir Roger, I would please give you the opportunity to reflect or maybe ask questions if there must be questions, I think, hearing all of this.
Well, I think I'm afraid I'm thinking that I have a very different view from the ones expressed by the other two. I mean, my view certainly is not that it's quantum mechanics, because quantum mechanics, as we currently understand it, is, well, as Einstein and Schrödinger said about it, it's an incomplete theory. I'm not as polite as they are. They were saying it's incomplete. I would say it's actually not even quite correct. And it's not correct because quantum mechanics, as it currently exists, does not have a theory of the collapse of the wave function. Now, you see, you have in standard quantum mechanics, you have the description of the world according to a thing called the quantum state. The quantum state evolves according to the Schrödinger equation, which is a deterministic equation, completely computable as well. However, it is not the way that the world evolves. As long as your system is small, in some technical sense of the word, small, then it does behave according to the Schrödinger equation. But when this system gets too big, and I could be more explicit about what I mean by big, when it gets too big, then it doesn't follow the Schrödinger equation. You have this phenomenon of the collapse of the wave function. And my argument is that it's not just that quantum mechanics is important for consciousness. Quantum mechanics on its own wouldn't give you consciousness. It's how quantum mechanics has to be extended to a better theory. As it exists, it would not explain consciousness. Quantum mechanics follows the Schrödinger equation, and following the Schrödinger equation doesn't give you what I need. You need something which goes beyond that, which is not computable. And the argument has to be in the collapse of the wave function. So I'm arguing it's worse than quantum mechanics, if you like. I'm saying what has to go on in the brain, in the conscious being, whatever its brain is like, that has to be something which is not just evolving according to current quantum mechanics, it's evolving according to that theory we don't yet have, which is the more complete theory in which the collapse of the wave function is part of that theory. So that needs to be there. And current quantum mechanics doesn't have a theory of the collapse of the wave function.
Yeah, you're dissatisfied with the theory, but please reply, Federico.
Yeah, no, I think Sir Roger is perfectly fine. In fact, I don't think that quantum physics is really complete, exactly because you cannot tell what causes the collapse of the wave function. We only know that the collapse of the wave function involves pure randomness, which is non-algorithmic, which is the only way that you can explain the behavior, according to the Bell theorem. It is a long story, but that's the characteristics of the collapse of the wave function. And in my theory, actually, we solve that problem, because by saying that a quantum field, first of all, we don't start by trying to explain consciousness and free will by quantum physics, because we believe that consciousness and free will are fundamental. Therefore, they exist as a postulate, and then because of their existence, we can explain why quantum physics must be the way it is, because it must reflect the existence of the comprehension, qualia and comprehension and meaning that exist in consciousness, and the fact that there is free will, which accounts for the collapse of the wave function.
But I think we touch here, don't we touch, and please reflect on this, Bernardo. Sir Roger, when you speak about your dissatisfaction, it remembers when you, in our previous interview, you also told me how Schrödinger, with his Schrödinger cat, didn't want to point to what the theory means. He wanted to point to its absurdity. And he wanted, of course, but then when I read sort of the early stuff and the philosophical thoughts that these founding fathers had, you see, of course, this same discussion. And what I found sort of interesting is that Schrödinger also started saying stuff that maybe consciousness is one in the end, and there's a unitary field of consciousness, stuff like that. So we see, I was very curious to ask you that question, because this really feels as if we're hitting ontology here. Isn't quantum theory weird as long as we want to keep up sort of an Einsteinian realist worldview, of which you are perhaps more in favor of? And then, of course, sitting here is our two gentlemen, perhaps a bit more in the other camp. But I want to let the three of you talk about this.
Before there is one more thing that I want to say very quickly. Okay. No, very quickly. It is the point that the fact, if you start with consciousness and free will, the fact then the quantum information has the same characteristic of an inner experience. That fact allows you to then say that the collapse of the wave function can be the result of a free will decision, because free will without consciousness would not make any sense. You see, it is exactly because you can explain consciousness that you can then explain the collapse of the wave function as a free will decision.
Yeah, let's see. Very clear.
Very different from my point of view. Yeah.
Do you see? Yeah, I'm curious on your thoughts, Sir Roger.
Yes. Well, you see, I would say the collapse of the wave function is a physical process which is a long way away from explaining consciousness. And the physical process is something one can get towards. I have arguments, which I put forward quite a long time ago, to show that the two great theories of 20th century physics, or the two great revolutions in quantum in physics, were A, quantum mechanics, which came first, and B, Einstein's general theory of relativity. And what I'm saying is that those two theories have an incompatibility. Quantum mechanics is based on the theory or the basic principle of superposition. You can have a particle in one location, that's one quantum state, or it could be another location, that's another quantum state. And according to the basic principle of quantum mechanics, you can have states where it's there and there at the same time. So you have all these superpositions between different alternatives. And that's very fundamental to the framework of quantum mechanics. And the fact that you don't see most of these superpositions is not explained by quantum mechanics. Now, on the other hand, general relativity has its basic principle, which is the famous, Galileo-Einstein principle of equivalence. Well, Galileo explained it very well. Imagine dropping a big rock and a little rock from the Leaning Tower of Pisa, and he knew that air resistance would make a difference, and a feather would drop more slowly. But if you had no air resistance, they would fall completely together. So as they fall, there is no, effectively, you cancelled out gravity. So gravity is the one force, if you can call it a force, which I'm a little bit dubious about. It's the one feature of physics which you can cancel by free fall. And that feature is incompatible with the principle of superposition. And you can make a little argument to show that they're inconsistent with each other. And to make them consistent with each other, you have to introduce this collapse of the wave function. It also gives you a measure of how much, when do you expect the collapse to take place? And it's not a complicated formula. There's a formula I produced, which was actually not original with me, because Ayyash had already found this formula about 2 years earlier than I did. I wasn't aware of his work, but I had this particular argument to show that his estimation of how long it takes for the wave function to collapse is in accordance with what my argument. Now, if I have an object, a big object, say like this magnifying glass of mine, and I put it in the superposition of here and here, that superposition would not last, well, it'd be a tiny, tiny, tiny fraction of a second. If on the other hand, it's a carbon atom or something, and here, well, it would probably, that superposition would last for longer than the age of the universe. So but there is a genuine formula which you can write down, which tells you how long that superposition would be expected to last before it collapses to one or the other. And it has nothing at that level, nothing whatsoever to do with consciousness. It's a physical formula. It's something which could be measured in experiment. It has not yet been, because experiments as they exist have not quite reached the level of sophistication in order to do this. There are experiments which are currently under being done. I mean, they're not there yet, but they're aimed at looking at this effect. And my hope is that they will see this effect when they get a little bit more sophisticated than they are just yet. And it won't be too long. When I say not too long, probably within the next 10 years.
And then to summarize you and then give you to the opportunity to respond to this. What I understand from this, Sir Roger, you have making a plea to. I've heard you say we should not quantize gravity, but we should the gravitization of quantum theory, right? So you see a much larger role to play for gravity there, and of course this has to do with quantum gravity. So in finding a unifying theory, what Sir Roger is talking about, which different angles or approaches do we have, and what do you see? What would your response be to this?
Well, I'm an outside observer, but I think the difference that Sir Roger is highlighting between their positions is not so much about the wave function itself, but collapse being an objective phenomenon. Sir Roger holds the position of objective collapse.
Yeah.
So he doesn't think that the collapse of the wave function is the consequence of a free-willed choice. He sees this as a physically determined moment related to gravitational mass. If gravitational mass crosses a certain threshold, the superposition will collapse into itself, into a defined state. So there is no free will there. It's a physical event. As a philosopher, the only conceptual, it's not a problem, but an issue to be discussed that I see there is, can we speak of physical quantities or physical variables before collapse? Can we speak of gravitational mass before collapse, before a measurement is done? But I think that is the key difference. It's not so much on the notion of what a wave function is a description of. There is very little doubt that the wave function has a deterministic evolution. We know how to calculate that. It's linear. It's the non-linearity process that we call collapse that is at stake here, and the interpretation of it being an objective physical process or a free-willed choice of the interiority of a system. Federico and I dare be with Federico on this one and not with Sir Roger. I don't think collapse really happens. I think if we eventually get to a deeper understanding of what's going on, I think we'll realize that there is no collapse. It's an epistemic. It's a transition from an epistemic idea to an ontological one.
Sir Roger is raising his hand to his forehead.
But
I don't see how you can say it doesn't happen. I mean, you have to have something which looks more or less like the classical world. And if you don't have the collapse of the wave function, the quantum evolution of a state does not look like the classical world. It just doesn't. I mean, there are arguments which people use, which are sort of approaches to this, but you can look carefully at these arguments and you see they don't do it. You have to have a development of quantum theory which has not yet been formulated in the complete theory. All I can do is say the level at which I expect collapse to take place. I say the collapse, if you have a physical situation where the parameters are so-and-so, then I might expect the collapse to take place within 10 minutes, say. And that calculation could be done. But it doesn't tell you exactly when it happens. It doesn't tell you which way the collapse happens. It doesn't give you a mechanism for collapse. It's just a formula which tells you how long a system can remain in superposition before it collapses to one or the other. And the connection with consciousness, you see, in my view, is quite secondary. And it's very important. I think I would certainly agree with both of you. It's very fundamental in the way the universe operates. Consciousness is playing a big role. But it's a subtle role. And it doesn't reveal itself until you have elaborate systems like living beings. As I'm aware, animals, maybe for all I know, plants might possess it to some degree. But I don't see it in inanimate objects. They're not sophisticated enough somehow to take advantage of the collapse of the wave function. But for them, it's just a random process.
But do you think that if we would reach a deeper theory that maybe goes beyond quantum theory, would we find out that consciousness is truly epiphenomenal at the end of the chain, so to speak, in our universe? Or could such a theory point to the fundamentality of consciousness? Where would you put your chips?
Oh yeah, I think it could do. I mean, if we understand, well, we need to understand the physics better, but I would regard that as a small step. We don't have the theory yet, but I would think within the next 50 years, we will have such a theory. I think that tells us we will understand consciousness in that time. It's a much more sophisticated concept. But what I am saying is the other way around, that whatever consciousness is, it's something which depends on that phenomenon. So we're not going to have a physical understanding of what things in the universe are conscious. I mean, even things like, you see, when I mentioned Stuart Hameroff earlier, I think I mentioned him. But anyway, the connection with the microtubules was something I learned from him. And his job is an anesthetist or an anesthesiologist. His job was to put people to sleep, except he doesn't call it sleep. It's a different phenomenon. General anesthetics are particular substances, and they have a very curious relationship to each other. For example, xenon, which is an inert gas, doesn't seem to have much in the way of chemical interactions, nevertheless is a general anesthetic. And what is the connection between these different substances which act as general anesthetics? As far as the chemistry is concerned, absolutely nothing. It doesn't seem to be they are chemically connected. But nevertheless, there is some physical connection, and the view is that his view, and I think he's probably right, his view is that these general anesthetics do affect microtubules, and it's the microtubular activity, which probably does involve the collapse of the wave function in their function, is something which general anesthetics affect. But that's a subject which is active at the moment and needs to be a lot of work to find out what's going on. But it's a long way from understanding consciousness. I think that's a much more problem.
Okay, Federico, please reply to Sir Roger.
Yeah, I had two main points. The first is that I feel that consciousness without free will is not useful. It's not useful in the sense that if you cannot, if you are conscious, and you probably should know your intentions, and you probably should know what the reality in which you exist is, so that you can decide how to proceed in your conscious living. But if you don't have free will, consciousness is really not useful, and so I don't see any reason why it should exist. So that's one. And the two things that I don't want quantum physics to explain consciousness. I start by assuming that consciousness and free will exist. And I arrive at describing why quantum physics must have the crazy properties it has to justify the existence of consciousness and free will that I taken as a postulate.
So here we really hit on an ontology also, right? In your interpretation of quantum theory.
The ontology is not in the quantum state. The ontology is in the meaning that the quantum state produces within the consciousness of the field, which is assumed to have consciousness and free will. Yes.
So yeah, it's basically a phenomenological approach. You say, I see phenomenology of consciousness with a private inner state that is non-clonable, which can hold sort of a free will that manifests in a certain action, and then you say that resembles very much what we know about quantum theory, so why not investigate that it could be that.
And that also explains why we have apparently two physics. We have quantum physics and classical physics connected by the collapse of the wave function. So the quantum physics describes the interiority of nature, and the classical theory describes the exteriority of nature. One is described within, in the realm of the Hilbert space, the other in space and time. The shareable information, the bits, derive from the collapse of the wave function according to the current theory, but in my theory, they derive from a free will decision of the quantum field that wants to pursue his own self-knowing, his own process of understanding about reality. Yeah.
So, Roger, I'm just very curious. I know this is not your ontological position, but I'm just curious in trying to solve the quantum conundrum, if you think it could be fruitful to pursue this route of saying maybe on an ontological level, we have to say the quantum fields are conscious, and out of that consciousness, the classical world sort of comes to us, as some of the founding fathers themselves seem to suggest. I mean, Max Planck saying consciousness is fundamental, derivative, matter is derivative of consciousness. What are your thoughts here?
Well, I think these things are very different. I think, for Franz, there's one confusion here, which I think I'd like to get rid of in a way. See, in the early days of quantum mechanics, people worried about the collapse of the wave function, but not thinking of it as a physical process. I mean, many people, including most particularly Wigner, I think, because I talked to him quite a lot when I was in Princeton. I had conversations with Wigner, which were very interesting. And he had the view, as many others did, that somehow the collapse of the wave function was an effect of consciousness. That is to say, the terminology in quantum theory is very much suggestive of that, because it says you make an observation, and this observation induces the collapse of the wave function. Now that you see, it's rather suggesting that the collapse doesn't take place unless a conscious being comes along and looks at it. Then that measurement that the conscious being makes by looking at it, if you like, collapses the wave function. So it's as though it's the consciousness which causes the collapse of the wave function. That's very different from my view. It's almost the opposite of mine. In my view, is saying, no. It's not that consciousness causes the collapse. The collapse would take place quite independently of whether they're conscious beings or not. I like to think of a particular example. I mean, just a sort of thought experiment, if you like. I imagine that there's a very distant planet somewhere which has very, very much like the Earth. It just happens that no life, no conscious beings ever came about on that planet. It is otherwise like the Earth. Now, the weather on the Earth is supposed to be very delicately dependent upon very small effects. So people talk about the butterfly effect. If the butterfly's wing flaps one way, then the weather goes one way. And if it flapped a different way, then the weather might have a completely different effect. So it's a thing which means that the behavior of the system depends very, very delicately on the initial state. Okay, now this planet that I'm imagining has no life on it, no butterflies. Nevertheless, you have weather on this planet. But since there is no conscious being or no beings which collapse the wave function, according to that view, collapse of the wave function doesn't take place. Therefore, you have weather, which is a superposition of all different weathers. And you have a space probe which goes to this planet and takes a photograph of the weather on the planet. Now, that weather, there's no conscious being on the space probe. It just takes a photograph. Now, as it returns to the Earth, it transmits this photograph, which is now of a superposition of different weathers. And somebody on a screen looks at the signal on the Earth, and as soon as that human being looks at the picture on the screen, suddenly collapse. The wave function happens, because only then does the conscious being become part of the system, and then the weather becomes one weather. To me, this is completely ridiculous. The weather is going to be one weather, whether there's a being on it or not. It's not because of living beings on the planet. It's not because of consciousness on the planet. It's because the collapse of a wave function is a physical process which takes place when things become large enough, superpositions become large enough, in a way which I could be very explicit about if necessary, what I mean by large enough, and it would collapse the wave function quite independently of conscious beings.
Yeah, I think that's a clear position, and it also sort of reminds me of Einstein, right? I like to think of the moon existing if I look or not. So I think you're in a very good company with this position. Bernardo, Bernardo, please respond to this thought experiment of Sir Roger.
Oh, no, not a direct response. Just an observation. I think we may be limiting ourselves to a dichotomy that maybe we don't need to limit ourselves to. The dichotomy I sense is it consciousness that causes collapse, or is it collapse that leads to a moment of consciousness? There is a dichotomy there. But the dichotomy presupposes the wave function to be ontically real. In other words, it presupposes that the world out there is actually in a superposition of states, a physical superposition of states. If that's what we start from, then of course, as Sir Roger mentioned earlier, then of course there has to be collapse, because when we look around, we see a world in a definite state. I think where Federico is coming from, may be wrong about this, but that's what I think, and certainly that's where I am coming from, is I don't think the wave function is ontically real. I think the wave function is a model of the best of our knowledge about the world. In other words, the superposition of states is our own gambling strategy about what we are likely to see next. It doesn't mean that the world is an actual superposition. And if the world is not in that actual superposition, in that sense, then there is no collapse. Collapse is an epistemic transition. It's the transition from what we anticipate to see and the probabilities we lay out about what we are likely to see next, and an observation of what is actually next. And you see what I mean? So maybe we don't need to limit ourselves to that dichotomy. Just a clarification point. That's all I'm trying to do.
And Federico?
Yeah, well, I have just a very simple point to add. In my theory, the ontic state is not the wave, the pure quantum state is actually the experience of the pure quantum state, which is within consciousness, and that's the one that then could cause the collapse of the wave function, which is not a collapse of the wave, a decision of the field to decide what to manifest in space and time. So the ontic aspect of reality is not in quantum physics is epistemic. In fact, that it can only tell us what we can know about reality. It doesn't tell us what reality is. So the actual reality is determined, if you start again with consciousness and free will, by those two properties that you have postulated from the beginning.
Interesting. So Roger, where are you on these epistemic versus ontic interpretations of the wave function?
Well, you see, there is a very important development in my thinking, which I don't quite know when I first thought it. Within the last 5 years, I would say, certainly. I think the first thing I ever talked about, there was a conference in Arizona, I think, the idea. But it got developed since then. That you can't talk about reality quite like that. There are two kinds of reality. There's quantum reality and classical reality, and they are not quite the same. And quantum reality behaves in a way which is quite strange. It's the notion of quantum reality actually comes from Einstein in a certain sense. He talked about a quantum state. He said, is the quantum state real or not? And a good example is the spin of a spin half particle. I take an electron. Now, the spin of an electron, the different possible spin states are spin right-handed about all possible directions. So I can move my thumb about the axis, and it spins right-handed about that axis. Now, all those different possible states, those are the possible spin states of an electron. Now, what you can't do is ask the electron what your spin state is, or you can try, but it doesn't give you any answer, because that's a quantum reality. However, if you do have a theory which says by now the electron ought to be spinning, say, about that particular direction, and it has all about the same amount, that's an electron, it's always the same amount, about that direction. Now, what I can do is I can confirm it, and this is Einstein's criterion. I can say to the electron, I'm going to measure the electron spin in that direction, and if I have it right, it will say, yes, you got it right with 100% certainty, and it will not disturb the system. You can measure it again and again and again, and each time it says yes. If I measure it in a different direction, it will give you a probabilistic answer. It will maybe say no, maybe yes, depends on, you do experiment many, many times, and we'll give you different answers. Now, the quantum state is something you can confirm, in a sense, but you cannot ascertain it. You have to make a distinction between confirming and ascertaining. Ascertaining would be something you say, hello state, which way you spin it? Doesn't answer questions like that. But you can explain these rather puzzling things, which is what Einstein was worried about, in fact. These things called Einstein-Podolsky-Rosen experiments, where you can have a spin state which is shared by two observers or two people, let's call them, widely separated. And you know what the total spin, each one has a spin half particle, which has come from a spin zero initial state, and so they have to be opposite each other. Now, if one of the individuals measured the spin in some direction, that instantly makes it the opposite, actually worse than instantly. It goes backwards in time along the past light curve. And the other one is fixed by the measurement made by the one. And the other one, if that other one could ascertain what the state was, you would then have a contradiction. You could send signals faster than light. But you can't send signals faster than light. It would lead you into contradiction with relativity. However, what you could do is confirm that state. If the other person knew what the measurement the first one had made, then that measurement could be confirmed. But it cannot be ascertained. And if you could ascertain it, you could send signals faster than light, which would lead you into real trouble. Relativity wouldn't work, it would be real trouble. However, you can make the quantum reality of that state is projected backwards along the past light curve, so it goes not just simultaneously, but even back in time. But since that's only quantum reality, you cannot ascertain what that state is. So you have to make a distinction between the quantum reality, which cannot be ascertained, but it can be confirmed. Classical reality can be ascertained. So you can ask the state what it is, and it tells you what it is. So that distinction is something which has to be made in order to talk about reality. So reality, when you talk about quantum mechanics, the notion of reality, you've got to be careful about it. It's not like classical reality where there is any one notion of reality.
I fully, that distinction is very clear to me. And you're talking about Bell's inequality theorem, right? And the loophole-free Bell tests that have been performed, I think, by now. And then a common thing I hear physicists say, we either have to let go of realism, reality, or we have to let go of locality. Is that true? But I'm curious.
Well, you see, it's not reality. It's quantum reality is not reality in the sense. You see, that's the trouble. One word for reality, then you lead to a confusion like this.
But if you look at the sort of more hardcore, so to speak, ontic interpretations, would you agree that those end up with like many worlds interpretations because you want the wave function to be ontic? And what's your take on that?
Not many worlds. No, I'm dead against it. Well, I have to be careful about this. I have a point of view. This has to be taken in the right spirit. My point of view is that it's a good thing to have had in certain stage of your life to have believed in the many worlds interpretation of quantum mechanics. The shorter period, the better. Shorter, the better. I did go through such a stage myself, of believing in the many worlds interpretation. But I can't remember how long it was. Whether it was as long as a year, I'm not sure.
And then one goes to a more adult position of an epistemic interpretation, or?
Well, you say, no, the theory is not really complete, or you have to understand that these notions of reality are more subtle. And without having the quantum mechanical picture, you say, I don't think philosophers could argue with each other endlessly without realizing this strange way in which quantum states behave. And I think spin is a good example. And, this is the Bohm version of the EPR, Einstein-Podolsky. But I think Einstein wanted to do it that way originally, but I think Podolsky talked him out.
As Sir Roger, may I lend your beautiful mind on a question that's been sort of stuck with me ever since we met, and I've discussed things with you. Yesterday we had an evening and we talked about semantics versus syntax, and we referred to Searle's Chinese room experiment, right? Can you get from pure syntax to semantics, which is a deep problem? What do you think there? To me, it seems impossible. The two seem two different categories, and that's why it feels as if I have to pick my ontology, is our universe in the end physical material, or is it conscious and it has to do with meaning? That's how it feels to me. But I'm curious here. What do you think about an experiment? Can we get from syntax to semantics?
You're talking about the reality of the world in something. Can we talk about the reality of the world in an objective way? Is that the sort of question we need? Yeah.
Yes, but it also has to do with what philosophers call qualia. If I have a taste of something, can we ever have a complete mathematical description of what I've experienced, which would make it clonable, copyable to another? And then, of course, it would. I don't see any objections that then we can have conscious AIs, because then you could have my conscious experience completely described, copied into a computer. But I sense that we have a fundamental problem there.
Well, I think there are some subtle differences here. You see, okay, philosophers and physicists worry about different things. Well, I'm not quite sure. Let me not say that too much. But you see, the computability issue is a separate question. I mean, that's a mathematical problem. Whether you can compute the thing from your physical theory or not. Actually, also, when you talk about qualia, I mean, we don't know. I mean, is the sensation of blueness common to different people? If I see a blue entity that creates a certain impression on me, and somebody else looks at the blue thing, and does that person have anything that you could say is the same as my experience? I would just say we don't know. It could well be that there is something in detail which is the same. We certainly don't know enough about that. But I find very curious things like synesthesia, where you have parts of the brain, if they get mixed up, but then one sensation gets sort of confused with another sensation. It does seem to be that there is something different between one kind of sensation and another kind of sensation, which may be a universal thing. It may be that different people, you might say philosophically, how can you ever know? Well, maybe someday we will be able to know. And maybe there is something about blueness, redness, or greenness or something, which is universal. And if you have synesthesia of some kind, maybe some people would see the blueness as green and so on. Possibly. I have no idea. I can't see anything against that, though. It seems quite possible that these qualia, if you like, are things which have some objective physical basis. I don't know. I'm not trying to claim that that's the case or not. I certainly think that as a present level of understanding, we're a long way from that. And we can talk about it in a more philosophical method. Okay, this one person has a certain sensation of so-and-so, and that's individual to that being, and it's meaningless to say it's the same as what somebody else feels. I don't know the answer to that. I think there could be
yeah, it's a clear position. Federico, you can respond or what?
Yeah, to me, qualia can be represented by a pure quantum state, but a representation of qualia is not the sensations of qualia. You know, a theory of reality is not reality, right? I mean, the quantum state, the pure quantum state, is the map of a territory which can only be known from within consciousness. So consciousness is what allows you to understand, to know and understand what you feel, which is qualia. And mathematics can only go to that point of saying the representation of qualia has to be a quantum field because it has the same characteristic. It's private, and you can only know a small part of what you can know from within.
Yeah, so what Sir Roger was saying, the blueness of blue, and that we cannot know for sure.
That is beyond what you can test, beyond what is testable.
And I guess this, because when you say the mathematics is the map and it cannot give us the territory, here, of course, Sir Roger, you have sometimes said that you do grant mathematics an ontic status, right? That there somehow is a mathematic realm of mathematics. Please correct me if I'm misrepresenting your view, but...
I'm not quite sure.
Sorry. I was talking about your ontology in the end. I think you have sometimes said that you think mathematics has some ontic status in our universe, that
there is a realm of mathematics, and that would say that it isn't only a map of reality, but it is like it truly exists.
Oh, I see. No, that's a slightly different question. Yes, I would say it has an existence, an objective existence. Well, sure, if somebody proves the theorem. I mean, Andrew Wiles proved that there were no x to the n. You can have a sum of two squares, which is another square, but there's no other power, which the sum of two that powers gives you another thing which has the same power. I mean, that's a mathematical statement, and that would be true whether the universe had different physical laws. I mean, it's completely independent. It's a mathematical statement which is objectively true. How we come across to understand why it's true may be a very difficult question. Maybe very few people really understand. I mean, how many people have gone through Andrew Wiles's proof, for example? I mean, not many. But I mean, I've never been through it, for example. But I still think he's right that the Fermat theorem that he established is objectively true. And if you had a different universe, well, not even a different universe, I'm not sure what that means exactly. But I could imagine a universe with physical laws which are not the same as ours, and they contemplate the possibility of conscious beings in that universe, possibly. We don't know enough about physics to know how unique these physical laws are. I mean, could you change the parameters which we have in our physical laws to some other numbers and have another perfectly good laws of physics, where the physical properties will be different? Possibly, we don't know. But the mathematical laws will be the same. So things like whether or not you have a sum of two powers which are the same, the Fermat theorem, for example, that's going to be the true whichever universe you're in. That, I think that's the thing you're referring to. Whether the mathematical world is an objective world independent of us, it has its existence.
Yeah, that is my question. And so you are saying that in some sense it is like in a Platonic realm of forms, it has a place, you say.
Yes, yes.
Bernardo, how do you listen to this as a philosopher?
Well, clearly the theorems of mathematics or the axioms of mathematics that are in logic, that are self-evident to us, have an application to the world, because we create these descriptions in mathematics and they are incredibly predictive. So stuff that is merely self-evident to us, because we are just primates. Why would stuff that is self-evident to our cognitive system hold for the world at large, right? There was a paper written by Eugene Wigner in which he talks about this miracle. He uses the word miracle 12 times, a 1960 paper. So I think this substantiates the point Sir Roger is making, that the mathematics is not arbitrary. It seems to have an existence independent of the minds that consider those axioms self-evident. To me, but that's just my philosophical position, I am aligned with Federico in this sense. I think the only ontological primitive is a field of subjectivity. And since to be is to have properties, things that are what they are and not something else they conceivably could be. So to be is to have properties. And it so happens that this field of subjectivity, which is mental, therefore, has archetypal patterns that are built in. It has a preferential way of mentation, so to say, certain things that it considers self-evident because it is what it is instead of being something else. And because we are segments of this field and so is the rest of the world, what we consider self-evident turns out to be applicable to the world. Yeah. But we can account for this without another realm. Yeah. We only need that whatever the ontological primitive is, whatever nature actually is at the bottom level, is the same for us and the world, and that we have subjective access to it. And then we can account for it without anything beyond nature.
I have a strange suggestion, but tell me if you're up for it, Sir Roger. I'd like to have a bit more of a poetic approach almost. If we read John Wheeler's with his notion of the participatory universe, it seems as if somehow the universe is writing itself. I mean, that's the classical world we perceive, right? And whatever the universe is, the world we perceive,
as observers is this classical universe, and we know quantum theory to be correct. So somehow it is as if the universe is writing itself. And we had a conference a while back with Lee Smolin, who you must know, and also saying a phrase that really stuck with me, that universe is nothing but a collection of partial views of itself. Also sort of this Wheeler notion. And I'm just so curious, what do you think? Is this all physicists talking poetry?
Maybe. I don't know. Of course, I knew Wheeler quite well. But he was a hard person to understand. And I always found it rather difficult. He was always very wise and everything. And I found it, if you talk to him, you have a question or you talk to him, and his reply would be about, 37.5 degrees away from your question. I'm not making that figure as an exact number, of course, but it was always a little bit angled away from what you thought. And it was quite strange in some ways talking to him. Interesting, but yes.
And but that whole idea of the people saying the universe wanting to know itself, the universe looking back at itself, all those stuff he pondered about, right? Because he did in the end he could not give the clear answer, right? But what are your thoughts there? Is it something that sort of also?
I don't know. I got lost after a while. He kept talking about ifs and bits and things like that, and I think I got lost at that stage. I guess it got too philosophical. I have to say, I don't know. I just find it difficult to. I think quantum mechanics confuses people too much. That's the trouble. And I think the trouble that confuses people is not quite for the reasons people think. I mean, it's partly because you have these two kinds of reality, and you can't really ask of a quantum state. You can't measure what quantum state is. And it's the same thing I said before. You can't ascertain the state. You can only confirm it. So if you think you know what it ought to be by now, then you can do an experiment which very, very precisely tests whether you got it right or not. But if you don't have any concept of what the quantum state is, well, it may be that you can't ascertain it. Like with these Einstein-Podolsky-Rosen types of experiments. You have to, I'm taking the view that you have to take this more, with quantum mechanics, there is a notion of reality which doesn't come about until you think about quantum mechanics. I don't think pure philosophy would give it. It's not a notion which comes from philosophical thinking. It's a notion which comes from physics. And it's interesting and different from what we tended to think before, where reality is something you might imagine. I've expressed myself on that before. But
Yeah, it's very clear. I think it would be nice to, because Sir Roger, I think we did not discuss a end time or we have already crossed it. So I don't want to. I want to respect your time and energy. So if the two of you have a final question for Sir Roger, maybe, and I have a question to all three of you to wrap this conversation up.
My question would be simply that if consciousness existed without free will, what do you think, what good would it do? I mean, I frankly cannot get my head around that.
well, you see, I think it's not, I mean, it's an interesting question because it doesn't seem to me necessary that consciousness is causal in some sense. I can imagine somebody being paralyzed completely. I mean, you get this happens. People are completely paralyzed and nobody can tell whether that person is actually conscious or not. And later on, you find that person may wake up in some sense and you find they were conscious all the time. They knew what was going on. It's just they couldn't influence anything. So in some sense, this notion of having free will in the sense of affecting things is not so obviously a necessity. From what I mean by I can imagine one can have a subjective experience without being able to use that to affect in a way. Seems to be something a little different. To be able to use one's consciousness in an effective way is a little bit different from actually having consciousness. So I'm not sure I would want to identify them perhaps as strongly as I think maybe you're suggesting.
Yeah, because to me, consciousness without free will would have no causal power. So it would do no good to any entity.
Exactly. It's not causal power, because if you have this person who is in a state, I forget the technical term for it, but who is simply aware of what's going on, but has no control over emotions and things like that, that person is still conscious.
But what would be the point of being conscious if you cannot do anything about it? You see what I mean? Yeah.
That's right. You can't do anything with it, but that's a different question.
Well, yeah, but you know, why should consciousness even exist if it has no causal power? That's my question. Yeah.
No, I would agree that clearly it does exist, and I think I agree with you there. It's the fact that it can have a causal effect is the only reason why beings have evolved with it. As you said, there would be no point in beings evolved who had consciousness if it had no effective influence on the world. So sure, I think that's absolutely essential. But it doesn't seem to me it's quite the same thing as being aware.
Have your views on free will shifted in the last decade? I mean, you have opened the door. I think here you say that the door's open for you to free will. Where are you now? Do you have free will?
Is that a question for me?
Yes, sorry, to you. Yeah.
Yes. Well, you said I have thought a little bit more about free will. I've often thought I don't really know what it means. But I think I would like to say that I have a better idea of what I think it might mean. And it depends on, you see, you could say, sometimes people think free will as, oh, you can have a will to do anything. Can you be random or something like this? I keep being reminded when I was growing up with my little brother, who was 2 years younger than I was, and he could beat me at pretty well any game. But the thing that disturbed me the most, he could beat me at paper, stones, and scissors, you see. Now, I thought that game is a pure game of chance. How can he beat me at that game? So I went away and I got hold of a table of logarithms out of my father's study, and I made a little table, 3 means this and so on. And so I make a long strip, and I would follow this strip and simply do what the strip said, and then I broke even. So I got relieved, you see. It's not that he was magic, and it's just that he noticed patterns in when I was trying to be random, you see. So free will is different from randomness. You see, sometimes people suggest that free will means you can do what you like, and therefore there's sort of randomness in it. I think that's the wrong way of looking at it.
I don't mean that, by the way.
I'm not saying this is your point of view, but I am saying that it's, if you like, the free will is to use to see, if I think action A is preferable to action B, and I have used my consciousness to work it all out, and I say, oh, I believe blah, 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 I go through it all, and I think, no, action A is probably the better thing to do. And then when the moment comes, then I do action A. And I'm doing the action A because I had the free will that it was involved in my understanding of which is better to do. It's not that, like when you touch the stove and it's hot and you put your hand away and things like that, which are clearly not free will actions. It's something where you're using your consciousness in a way which involves your understanding of what's the right thing to do. And it's more like that. So it's not a complete answer to the question. But
I dare, by the way, disagree when you both of you say there would be no point in no free will and consciousness, because say we have a movie theater. I can enjoy a beautiful movie without being able to influence any of the scenes. The thing has been recorded and it's playing out. I can still enjoy it, which would be a conscious experience. So
and that's I agree.
Okay, there, Bernardo. Yeah, I think this one is also hits on when you as a philosopher think about free will versus consciousness, and you don't see the necessity of.
I don't deny free will. I just think the concept is not precise. So people mean different things. Like we think that if something is determined, then there cannot be free will. But that's not what we mean when you talk about our free will. It's like my choices are not random. They are determined by me, my tastes, my preferences, my inclinations. So it's not like free will is dichotomous with determinism. It's about what is determining it and what we identify with. If we identify with the causal factors that make the determination, we say, oh, free will. But if we don't, we say, oh, we don't have free will. Well, you see, it's not a dichotomy. It's not contradictory.
Yeah.
But I am with you that I think there is still, well, I think the search for truth should not depend on what makes us feel good or not. The truth is the truth.
Of course.
But even if the truth turns out to be that the universe is determined, I would still see room for what we colloquially refer to as free will, because then the factors that are making the determination are those factors that I identify with. I am making those determinations. Now, never mind that I can't be other than I am, so my choices will always be determined by that which I am. I can't will my will, like Schopenhauer said. I can only act according to my will, but I can't will myself to will differently. So at the end, does it matter? So, but I understand how you use the word, Federico. You talk about free will as a impetus that leads to changes of states.
Absolutely. That's exactly right.
Yeah. So that I could call that determination too, and it would still have the same effect.
Yeah, but it is a determination that has origin on an inner state as opposed to a objective collapse of the wave function, for example. Yes.
An inner state that you identify
that I identify with, which I have control over. Which I have control over. I can choose where to look, or I can choose what I feel, what to say, or what I feel. Okay, those are the bottom choices. Are only choices of what do I communicate, what I choose to observe, and what I choose to communicate, which is something which is within me. Yeah. So those are the only choices that are considered free will, because the rest of it is just it confuses the idea of what free will is. So I'm quite in agreement with both of you when you consider free will. I can do whatever I want, and that's absolutely silly. Okay, yeah.
And if we're all okay still, in your book, Federico talks about the fact, Sir Roger, that we are quantum classical machines, so to speak. Our physical body is quantum classical. Now, if this evidence is right, that has just come out, and there's now a discipline called quantum biology, that thinks these phenomena are much broader. We see them in nature, these quantum classical aspects. Could that mean that consciousness is not restricted to brains? I mean, if in biology we see quantum classical phenomena on cellular level, what are your thoughts there, Sir Roger? Do you think consciousness could a bacterium be conscious, for instance, or?
Could be. The thing is, I don't know. You see, I think consciousness is certainly not restricted just to humans. That I'm certain. But how far down, if I can use the word down, in the animal or even plant, and how far does it go? You see, I think, if people, dog owners, are very convinced that their dogs are conscious, and I believe that is correct. I have no reason to disbelieve that. I think that dogs are conscious. I think that elephants are conscious. I think that octopuses are conscious. They don't have to be mammalian at all. But whether an ant is conscious or not, I won't worry more about. Maybe, maybe not. Whether a honeybee is conscious, maybe a better chance to think that they do complicated things. They seem to be able to even do simple arithmetic, apparently. So how far down, if I can use the word down, in the animal kingdom it goes, I have no idea. I think it probably goes pretty far down. Whether a bacterium could be considered to be conscious, I would be much more dubious about. But I'm only guessing.
Yeah. But sorry, just one, because I'm so curious what your thoughts are. In people have like panpsychist ideas when they think, let's say a cell is conscious, and then they have what's called the combination problem, because how then does do I feel like one consciousness hunts and not sort of a sort of weird sensation of being trillion cells at the same time? Are these stuff that you think about or have thoughts on?
Well, it's got to be something. So I do think it's got something to do with the quantum state, and since I argue it to be to do with the collapse of the wave function, then you've got to have a wave function to collapse, and big wave functions collapse more than little wave functions in a certain sense. So according to such a view, you would have to have quite a big coherent object. You see, it's wrong probably to think of individual cells. It's probably a collective effect. I mean, many quantum effects are like that. When you talk about superconductivity, there are many quantum effects which are quite big in a certain sense, of extensive quantum fluidity, things like that. Sure. So it's not just thinking of it as individual atoms, how much does each atom have, and add it up. That's not the outcome. It's got to be some much more collective definition.
And I have one final question for the three of you. Maybe Federico, nice if you can start. We've discussed the dangers and the threats of AI, especially as things are now progressing so fast, and especially, and here also, Sir Roger, I remember you saying it's not, we don't have to fear computers being intelligent. What we have to fear is that we start believing they are truly intelligent. So I remember you saying that. And what if I asked the three of you, what defines the human? And could we say that the era of computation points back at us that we are much more? And so more of a bit of sort of on a meaning purpose level, what are your thoughts here? So Federico, what defines the human?
If a human is defined by having a consciousness that is not actually in the physical body, is in the field that controls the physical body. And so the sensations and feelings and free will are properties of the field. It's a quantum field, doesn't exist in space and time. So if you believe that, then a lot of our intelligence, our real intelligence, what distinguishes us from artificial intelligence is the semantics, is the fact that you have an experience, that you can comprehend what you are experiencing, you get the meaning of it, and that, of course, is the ontology, as I said earlier. So symbols follow the ontology of the meaning. So these symbols are, in fact, in service of the fact that these fields want to communicate with each other, and they need classical symbols, which are shareable symbols, like bits that can be copied to communicate. They cannot transfer what they feel directly, because that's a quantum state that cannot be duplicated. So it's impossible to communicate what you feel to any other field, but you can communicate by translating some of what you feel into shareable feelings. And that's also accounts for why there has to be a classical world. Classical world has to exist for two reasons. One, to communicate, field to field, to communicate their meaning with classical symbols, with shareable symbols. And the other one, to store the experience, because the actual experience, the quantum experience, can only last a very short amount of time. So it's actually in the present. So you need to store that experience with classical symbols that you can then retrieve in the present in order to make sense of of your life.
Thank you. Yeah. And Bernardo, how would you like to close that? What defines the human, and especially in relation to the era of computation?
What defines us is our inner life. Whatever it comes from, what defines us is what it is like to be us, right? Not how we present ourselves to external observation, but what it is like to be us. I don't think there will ever be anything it is like to be a silicon computer in and of itself. I think assuming that there can be is mistaking a simulation for the thing simulated. It's like thinking that if you simulate a black hole in your computer, which you can do very accurately, you will be sucked into your computer because your simulation is accurate. And I think the same thing with AI, that it simulates how, or the patterns of how we associate tokens, words, word segments. The fact that it can simulate that well because it has been trained on text written by human doesn't at all mean that what it is like to be it while it is processing tokens is anywhere near what it is like to be us when we are speaking. As a matter of fact, I don't think there is anything it is like to be it in and of itself. A large language model is just a computer that applies geometrical transformations to tokens. It's manipulation of symbols, like in Searle's Chinese room experiment. And I think it is a great danger that because those symbol manipulations now can be done at such a large scale, that LLMs come across to us as things like us, the illusion is now becoming so compelling that we will start thinking that we are mechanisms, or in Sir Roger's words, that we will start thinking that we are formal systems, because those LLMs are formal systems and they seem to behave like us. Now, where does the illusion come from? Well, it's obvious. It seems to behave like us because it was trained on our output. It was trained on human text. So it quacks like a duck because it was made to imitate the duck. So the fact that it quacks like a duck doesn't mean at all that it is a duck, any more than because a shop window mannequin that was made to look like a human, that similarity doesn't mean that it is human. It was constructed to look like a human.
By humans.
By humans. Yeah. An LLM was constructed to talk like humans, by humans, trained on human text. Yeah. So that it quacks like us doesn't mean that it is anywhere near us, but the illusion is so compelling that we may start believing this kind of grotesque nonsense.
So, Roger, would you agree to this? Are your views on AI still the same, even with the last developments?
I think I don't think that my view has changed on the whole. The trouble is that you can get devices. See, I think that without being conscious, these devices will not actually, well, put it the other way around. Well, they won't be intelligent, if you like. And I think AI is a misnomer. See, it means artificial intelligence. And in fact, the fact that one calls it AI is rather suggestive, well, it is suggestive, that you just have your powerful enough computer and then it will become actually intelligent. Now, you see, for me, this goes against, the initial argument which I was trying to make at the beginning of this discussion came from the lectures given by Steen, which I formulated my viewpoint there. What he showed is that your understanding really is not a computation. So you can put in as much in the way of computational power. You can make the thing play chess as well as you can, or you can make it play Go so that it would be play these moves better than any human being might. That's quite possible. But does it understand what it's doing? Well, it would have to be conscious to understand what it's doing. Of course, it's hard to formulate this, because what does it mean to say it understands something? It might perform in such a way that looks as though it understands it. And the trouble is that I can imagine that the technology will get to such a degree that it's very hard to tell whether or not it's conscious. Doesn't mean that it is conscious. And I certainly would argue that a computational system, in other words, computer, when we use the word computer, that's what we mean after all, a computer in the sense that we mean it, which is a computational system, will not ever be intelligent. Doesn't mean that it couldn't simulate the intelligence to a degree that you might be fooled by. I mean, it's a difficult question, but I would say that AI, it has its dangers. The dangers are not that it will take over and become more intelligent than us. The dangers are that it will be misused in ways which could fool us. All that sort of stuff.
And yeah. Thank you so much, Roger. And I cannot, I find it very special that you took time for us. And I also find it just very special. I contact your assistant, and that you are still up for this, sitting down with us. And I see a bookshelf full of books. Are your days still spent? Are you still every day reading, thinking? How does that go on your age?
Still have my books because I don't want to throw them out. But I have the difficulty that I can barely read because my eyesight, I have macular degeneration, which means I have to magnify it up hugely in order to see it. I should probably get one of these reading devices on my computer which can read to me. I haven't done that yet.
But your days are still spent thinking over all these deep problems. You are in that sense still working.
Yeah. It gets more difficult as I get older, I think, yes. I get tired more easily.
Thank you so much. And
I cannot do more. I cannot do more than thank you very much, Sir Roger, because this has been a very, very good discussion. Thank you.
I've enjoyed it too.
Yes.
I'm very grateful as well. Thank you.
Thank you so much, Sir Roger. We'll let you and your assistant know when this video comes online. And I wish you all the best and both of you in finding answers to these deep questions. And it's also beautiful to just discuss and ponder about these questions of life. Thank you very much for watching. And we will let you know when next videos come up around all of these topics. Thanks so much.